Welcome back to Next Now, your inside track on the infrastructure shaping the AI era. I'm your host, Nexus, and if you're enjoying these insights, make sure to subscribe. And you can also catch us on Spotify for your commute or workout. Today, we're diving into how universities worldwide are transforming themselves into AI powerhouses and why infrastructure investment has become the defining factor separating leaders from followers in global academic innovation. The landscape of higher education is experiencing a fundamental shift. Universities aren't just teaching AI anymore, they're actively shaping where it goes next. And the institutions getting this right are discovering something remarkable. AI infrastructure isn't just an expense line item, it's actually a powerful financial and reputational accelerant that creates a virtuous cycle of funding, research excellence, and global recognition. Let me paint you a picture of what this looks like in practice. Take the University of Florida, which made a bold decision to rebrand itself as an AI university. They invested $70 million in HiPerGator AI, powered by H100 technology, through a public-private partnership. The results? They're now supporting over 800 AI projects, including Gatortron GPT for medical note drafting. But here's the kicker. This isn't just academic research happening in isolation. They've explicitly positioned this infrastructure to improve lives, bolster industry, and create economic growth across the entire state of Florida. Then there's Oregon State University, launching a $200 million innovation complex with a $50 million gift from NVIDIA's founders. They're deploying H100 and H200 powered systems that accelerate research from conception to market in climate, robotics, and materials science. This isn't just supporting their regional economic strategy, it's actually helping attract state CHIPS Act funding. And Princeton University took a different but equally strategic approach. They invested in a 300 GPU NVIDIA H100 cluster specifically for open generative AI research. This allows their labs to train large language models at scale while retaining intellectual property and fostering collaborations. As they put it, this ensures academics remain part of the conversation in AI progress, rather than being sidelined by industry. But perhaps one of the most fascinating examples comes from Denmark. Their Danish Centre for AI Innovation operates Gefion, a national AI supercomputer equipped with over 1,500 NVIDIA H100 GPUs. What's brilliant about this model is that it's funded jointly by the Novo Nordisk Foundation and state investment, serving as a cross-sector resource that connects universities, startups, and enterprises. The commercial outcomes are already flowing. Lundbeck, the pharmaceutical company, is partnering with DCAI to leverage the supercomputer for AI-driven molecule discovery and drug optimization in brain disease therapies. According to DCAI's CEO, this demonstrates the game-changing potential of AI supercomputing in tackling urgent healthcare challenges. We're seeing academic research directly accelerating treatments that could reach patients faster. And here's where it gets really interesting. These university investments are spawning real companies with real market impact. Take Six Estates, a fintech AI startup that spun out from research at NUS and Tsinghua University. They deployed an NVIDIA DGX base pod with H100 GPUs and achieved 4 times faster GPT-3 model training and 30 times faster inference. That's the kind of performance that translates directly into competitive advantage and rapid product development. So what's driving this global transformation? I see 4 key shifts happening simultaneously. First, universities are becoming innovation engines. When you have high-performance AI clusters on campus, you can tackle complex global challenges while retaining intellectual property, launching spin-offs, and attracting major industry-backed projects. It's a complete reversal of the traditional model where universities just publish papers and hope someone else would commercialize the research. Second, we're seeing the power of public-private partnerships. Strategic collaborations with governments and corporate leaders are unlocking the funding, infrastructure, and scale needed to drive regional economic growth and accelerate R&D timelines. These aren't just procurement deals, they're genuine partnerships that leverage everyone's strengths. Third, research to impact cycles are compressing dramatically. When researchers have on site access to cutting edge AI hardware, they can train models faster, iterate rapidly, and get innovations to market at record speed. The traditional gap between academic discovery and real world application is shrinking. And fourth, world class infrastructure is becoming a magnet for talent and investment. Top tier faculty, high performing students, and large scale grants are all gravitating toward institutions that can provide the computational environment that cutting edge research demands. The impact extends far beyond computer science departments. When universities deploy advanced AI infrastructure, the effects ripple across every faculty. Climate scientists can run ultra-high resolution models to predict environmental shifts and uncover patterns once hidden in complexity. Medical researchers can explore genomics and personalised healthcare at unprecedented speed and scale. Engineers can simulate real-world systems in incredible detail, optimizing designs and materials before anything is physically built. Even fields you might not immediately associate with AI are being transformed. Legal scholars and ethicists can engage directly with AI's societal implications, shaping the governance frameworks we urgently need. Linguists can preserve and revitalise Indigenous languages using AI-powered tools. Educators can build adaptive learning systems that personalise teaching and meet students exactly where they are. But here's what university leaders need to understand. This window of opportunity won't stay open forever. The global race to lead in AI is accelerating, and the gap between institutions with advanced infrastructure and those without is widening rapidly. Major research grants, especially for AI-intensive or sovereign technology programs, increasingly require access to advanced, high-throughput computing environments. The ability to publish high-impact, data-driven research is directly tied to infrastructure capability. Without it, global academic standing erodes. Today's students expect hands-on experience with the tools that will shape their careers. Institutions that can't provide that experience risk losing top-tier candidates to better-equipped competitors. And leading AI academics simply won't join institutions that can't support the scale, complexity, and speed their research requires. For university leadership, this creates a series of critical strategic questions. Can your current environment handle training large language models, generative AI, and multimodal systems? Or are you approaching critical limits? How quickly can you scale compute capacity for surges in research demand, competitive grants, or national initiatives? Is your infrastructure elastic enough to support burst capacity and cross-institutional collaboration? The good news is that universities don't have to build this capability from scratch. Working with specialised providers offers significant advantages. You can shift from capital expenditure to operational expenditure, avoiding large outlays and long procurement cycles. You get access to AI-optimized, certified facilities designed specifically for dense, high-power AI environments. You can scale on demand without waiting on construction timelines or hardware availability. Perhaps most importantly, you can focus your teams on research and innovation rather than infrastructure management. Expert providers handle power, cooling, uptime, compliance, and security, the complex operational elements that can distract from your core mission. For institutions in Australia and the Asia-Pacific region, there's a particular strategic advantage in working with providers that understand the unique requirements of academic research and the importance of data sovereignty. Having infrastructure located near major international subsea cable landing stations enables ultra-low latency connectivity for cross-border collaboration, federated learning, and edge computing applications. The institutions that are moving decisively now aren't just upgrading their IT, they're positioning themselves to lead in the AI era. They're creating environments where breakthrough research can happen, where students get hands-on experience with industry-leading tools, and where academic discoveries can rapidly translate into real-world impact. The global AI research landscape is being redrawn right now. The universities that invest strategically in advanced infrastructure today will be the ones setting the research agenda, attracting the best talent, and driving innovation that matters tomorrow. Whether you're a chancellor thinking about institutional strategy, a dean planning new programs, or a CTO evaluating infrastructure options, the message is clear. The AI infrastructure decisions you make today will determine your institution's position in the global innovation ecosystem for the next decade and beyond. The race is on, and the starting line is infrastructure. The institutions that recognise this reality and act decisively will be the ones writing the next chapter of human knowledge and discovery. Thanks for tuning in to Next Now. If you're building or scaling AI infrastructure and want to know what ready for AI actually looks like in practice, stay with us. More insights coming soon. Make sure to subscribe to our YouTube channel and catch us on Spotify.